If we're going to study motion, then we need to make sure we can use the correct terminology quickly and precisely. So this is a quick overview. We're going to be using scalars and vectors, with vectors obviously being the ones that have got magnitude and direction. Displacement is the distance moved in a specific direction. If you get up, walk around the room, and sit back down again in the same seat, your displacement is approximately zero, even though the distance walked is not zero. Speed is often thought of as distance over time, but it's better to say that average speed is the total distance travelled divided by the time taken. This more precise definition allows for the fact that speed may not be constant, and also gets in the idea that we want delta t, not just t really. So, average velocity is displacement over time taken. Since we are only going to work with constant acceleration, which means a velocity time graph is a straight line, we can get the average velocity from the average of the initial velocity u and the final velocity v. And speaking of acceleration, that's the change in velocity divided by the time taken, delta v over delta t. Plotting velocity time gives the acceleration from the gradient and also the displacement from the total area between the line and the time axis. Plotting displacement time gives velocity from the gradient. Useful vocab for graphs is to describe a flat line as a constant velocity, a non-flat straight line as increasing or decreasing velocity, and a curved line as velocity increasing at an increasing rate, or increasing at a decreasing rate, etc. Okay, I just use velocity there as an example. There are a number of different equations you're going to be using as well, depending on what you know and what you want to know, but that's another video.